instead of making dinner, I had another idea. Because right here we are calling functions. Wait, what? Why is this? Oh, it's function already defined. Right, so we see here panel count. Yes, we got two functions called panel count. So this is panel count. So here we just say size of the biggest cube, just say n. Size is 1 and size x is just n, and plus 1, size plus 1, that's one thing. And panels used, number of panels used in cube n is also used just once. So we comment this out, and also the panels used, I say just panels used, we equal that to this thing. Just replace those variables with size. I got a bunch of cube x thingies. Well, not, let's just call that cube x. Here we say cube x cube x. All right. So yeah, that's panels used. We can comment this out. And then panels use, number of panels by rectangle by template with zerums. Yeah, then both times method is called. Is there anything wrong? Like here I see some errors with some irrelevant stuff. So here we do that in scaling, see if so here's, and it takes 13 seconds. It actually takes less time. So let's incorporate that, you know, that's actually a good one. So here we come, so to test it out, look. Here we come to 98836. And here we just say, like so. Just say cube x times 2, or cube x times cube x. I smell a scented candle, what the fuck. Cube x times 6 plus 3 times cube x minus 1 times cube x times cube x. Alright, we make an attempt with that. because you know it was faster, like 0.02 second over here. You know, this is only 1.13 and this is 1.15, so it should be more. Oh, it's the same. Why? This is so weird. Why is it the same? You know, and over here we could just say size of the biggest cube. Can just comment that out. Cube x, well, cube x, cube x, cube x, cube x. Copy, reload the whole page, delete that, paste it, test it out. X is not defined. Okay. Times n. What? Did I mess up here? 3 times cube x. Where did I mess up? Oh. Comment this out, of course. It's still wrong. Say what? Let's make that more verbose. N times 6 plus 3 times n minus 1 times n. Well, did I just mess up my code somehow? This one works. let's copy it, paste it over here. Why is it suddenly failing? Yo, what the fuck is going on? Test. So, I just don't understand, man. Let's paste that over here. Alright, this is green. Six. So instead of calling that function, copy, paste, copy and paste, and we say code X, code X, code X, code X, and code X. Yeah, we test it out. Cube X. What the fuck it's... I hope that will run faster. Oh. Why? You for real? Cube X 1 while cube X on the power of 3 is less than n. What do? Cube plus equals 1. Oh, we still call it over here. Oh, we should say you can. This code is funny. Like right now, we just say, yo, you can't call that function because it doesn't exist. But it called it anyway. Yeah, what the fuck, man. Alright, so here plus 1. And we want to say cube X cube x minus equals 1 at this point. So we test that, it should still work. Invalid syntax, fair. Test it out. Cube x and comment that out. Oops. Can attempt. (98836). It stays at 98836. And if I copy that, get out, open it again, paste it as a plain text over, test it. Alright, make an attempt. Okay. Alright, so I see there is a need for further optimization, especially with this one, because it doesn't even get through the basic fucking test, man. And the remainder is only like, come on, look, the remainder is only like, I don't know, 1,164 tests. And the thing is that everything I do seems to not affect the amount of tests that are executed, and not even a little bit. Not even a little bit. The only thing that did was me like making the code work. That had a positive effect, I think. I think it had a positive effect, I'm not sure anymore. 9875, yeah, it did improve it for a couple of hundred. I guess I need to, what is numpy? Maybe I could, who uses it and why? Absolute beginners wide. I don't want numpy array. Adding, removing, inserting elements. Yeah, I don't want, like, okay. Can you reshape an array? I don't care. I don't care about your fucking arrays. I'm way over them. Since this program needs fucking centuries, literally centuries, to count to the proper number. How to create an array from existing data? I don't care. Okay. Broadcasting, more useful array. And reshaping a matrix. Generating numbers. Generating matrices. 2D array or matrix. So 2D array is just matrix. How to reverse an array. How to access the docstring for more information. Working with mathematical formulas. Alright, basics. Data types. Boolean. Arrays, scalars. So the main thing is like array. Input and output. Indexing. Why is my computer running so fast? At least now I can check by writing top command. Kazam. X-Oraga. Brave is eating quite some. Wow, Kazam is running for quite some time today. Or now, I don't know. And even I saw Thor there. I don't know. Yeah. Learner profile. Oh, here's quick start. Advanced indexing, less basics, copies and views, shape manipulation, linear algebra. Alright. Work in progress. Fuck. Automatic reshaping. It's all about arrays, man. It's all about arrays. Why is NumPy all about arrays? Why is this code so slow? Come on, like... Oh, I think I need to go back and check that profiling methods, check this guide until the end, Yo, my kitty sneezed. Profiling trace module, so it says advice section is profiling document. Run snake run. Alright, so yeah, let's advance from there to see how we can profile our code, and maybe it's even like good to know if we can maybe just again restructure our code. Like we did it 3 times now. We did fucking 3 times now. Each time is better. Now it just needs a little bit better. But how? I'm kind of running out of ideas. Hehehe. Kind of running out of ideas, because this test suite makes it really hard, because there is like literally 10, like how much is it, like 100,000 tests. 100 fucking thousand tests, man. That's like, we need really a basic return. We need a basic calculation to solve this. Yeah. Let's make dinner. Alright, let me unpause this. Yeah, that's my Firefox. This is my Brave. Yes, that Jake. Handling large numbers in Python, that's no issue for us. Not just .NET. .com. A bunch of interesting people on the internet, and we stayed here with so it says profiling code. What is code profiling? To help identify performance problems without having to touch their code. Profiles can answer questions like how many times is each method in my code called and how long do each of these methods take. That's that. We make an attempt on this one. Again, it shall just time out. And everything is correct up until this point. And we're redirected. Oh shit. We are directed here. Part-18. Below is a table comparing the performances and features of various profiles to Scalene. So why Scalene is the best? Okay, fair. I guess the author is very proud of that. But to me it just says nothing, you know? I only know that Scalene is the best. Output: Scalene prints annotated source for the program being profiled as text or as HTML via the HTML option. Scalene API and the HTML option. That's the HTML option, which is kind of a lot of data. It's really lots of data. Same directory. You can optionally have profile all. Here's a snippet from there. Memory usage at the top. Use Scalene. The following example program with help. Optional arguments. File to hold profile or output as HTML. Okay. I'll execute not just target program. Default only the target program. Profile only code and files that contain the given string. Use virtual time, sampling rate. I mean, I guess that if you just say Scalene app.py, you got basically says that over here you spend 51% of the time, and here is 22% of the time, and here is 22% of the time, here is 5% of the time, and that's it supposedly. So what if we try to just mix this up first? This takes 0.16 seconds. Let's do it again. 65:14. Let's do it again. 67:7. Yeah, it's always a little bit different. And it's, yeah. So now we say here say, oh shit, let's say size 3. Save that. Let's see, 79%, and it's still, oh, that's a lot more seconds. Oh shit, that's like half more. Shit, it's like half more. So yeah, we better use just size times size times size. We're way better off that way, because it just takes less time. And what do we need? We don't need to. So let's check. Right now, probably all of the code would take around so that is 135 seconds plus, for example, 14 seconds just to be sure is 149 seconds, and if 149 is to be brought under 12 seconds, so 149 seconds divided by 10, maybe, alright, we can say over here, say just shit, 13775, so we're 13575 plus what is needed, like 12, maybe 14, for example. So we're 149.75 divided, let's say 12. Alright, that's still too much. 13. Yeah, that's like living on the edge right there. 14. So our code needs to be like 14 times faster, or I mean at least 13 times faster than it is right now. So for example, this needs to be run in like 0.02 seconds, or yeah, let's say like 0.02 seconds or something like that. So yeah, what to do, man? What to do? Because now we see most time Python, time native. There may be some good. Okay, so we got that bitwise. Expressions, key value. Let's say Python over here. Let's go to documentation. Success stories. Well, we could read about that. I could read about that later. Shit. You always find interesting stuff. Alright. And we say here we also got a book, Code Tuning Strategies. 587. Introduction to Code Tuning. A summary of the approach to code. Let's read summary of the approach to code tuning. In here is 606. 606. You should take the following steps as you consider whether the code tuning can help you improve the performance of a program. Develop the software by using well-designed code that is easy to understand and modify. If performance is poor, save a working version of the code so that you can back to the last known good state. Measure the systems to find hotspot. We did that. Determine whether the weak performance comes from inadequate design, data types, or algorithms, and whether the code tuning is appropriate. If code tuning is not appropriate, get back to step 1. Tune the bottleneck, identified in step C. Measure each improvement one at a time. If an improvement doesn't improve the code, revert to the code saved in step A. Typically, more than half the attempted tunings will produce only a negligible improvement in performance or degrade performance. Repeat from step 2. Algorithms and data types. And there is Knut Donald, The Art of Computer Programming. Performance. Performance is only one aspect of overall software quality. It's usually the most important. Code tuning techniques. Stop testing when you know the answer. So you say don't have like ternary operators when you know what's the answer. So yeah, here is like only necessary stuff, it seems. Okay, that's one thing. Add a break statement after the negative input found is true. See example of not stopping after you know the answer. Okay. I do not remember, like, but if we just say I want to print out the return size and also print size. First to say that, I think nothing is printed. Oh, 1. And that is printed, I guess. And that takes 16 seconds. And I say here size is 1 if x is less than n 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, else x is how much? And 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, say here save, and we run that. Oh, else it's 1, else so I don't know, 3, 0, 0, something 30 or 2. Yeah, let's say 2 now. It's only 40, 28. It only takes 0.8 seconds. That's more like it. 4, 9. Alright, so I say that. Copy that thing. Paste it here. And we tested it for this one. Alright, so we'll say, I don't know which one is the appropriate one. If it's, oh fuck, say 1, 2, 3, 4, 5. I say 1, 2, 3, 4, 5. Change it to 3. So over here we just do that. 1, save. That happened really fast, I guess. 1, 4. So 4, 6, 4, 0, 0, 0. 4, 6, 4, 0, 0, 0. So we say 4, 6, 4, 4, 6, 4, 0, 0, 0. Now this code is 0.03 seconds long. So that's doable now. And we say everything, like 100% is spent here. Say, what the fuck? Again, 100% is spent there. I don't know if it can be faster. What about our beloved previous example? Which I forgot. At which number did it start? I guess we have to, oh my god, but it was hidden. The discussion is hidden, so I can't copy and paste from over there. Yeah, I can't find it yet. It's here for sure. Not exactly here, but we know it's 18 zeros, so it's like that's 17 zeros, that's 18 zeros. Save. So we test that against 18 zeros. Yeah, see how much time it takes. Here is 50, 10, 26, 4 and 0.16 seconds. Yeah. Now is there a way to say if x is more than that, else 4 times x f. But yeah, there is no use in optimizing this part of code if the tests even don't come to like this big of numbers. So it's a short logic, stop testing when you know the answer. Results using break keyword, time savings C++ and Java. Once you've determined that x is not greater than 5, you don't need to perform the second half of the test. So here we check for if rooms left to construct minus cube x and that. And yeah, that's not testing correct. Fuck. Order tests by frequency. Arrange tests so that one that's fastest and most likely to be true is performed first. What is the name of this program? Visual Studio. Compare performance of similar logic structures. Okay, use lazy evaluation. One of my former roommates was a great procrastinator. He justified his laziness by saying that many of the things people feel rushed to do simply don't need to be done. If he waited long enough, he claimed the things weren't important would be procrastinated into oblivion. He wouldn't waste his time doing them. Lazy evaluation. straight time code tuning time savings. Switching refers to making a decision inside the loop every time it's executed. If the decision doesn't change while the loop is executing, you can unswitch the loop by making the decision outside the loop. Usually this requires okay, I'm frustrated because look over here, if we are testing with this, for example, and if I do that, because we also need to optimize for these things, so if we do that, program did not run long enough to profile. So we say Selene program did not run long enough to profile. Well, wow. Okay. I could maybe run it multiple times. Reduce profile. Oh, what? So if I use anything, I can do that. Wow, that's an interesting thing. Set down and then profile interval every 1 second. 0.01. 0.001. Okay. CP only, profile all, use vertical time. Yeah, so the problem is that it's not run enough times. So we say for x in range that x. Alright, I think that's long enough. Hehe. Oh. Alright, to get okay, so there is even 0 time spent over here, and we spent quite some time in this print function, a bit even over here, elif1, that spent 1%. Wow, that could be optimized. Panels used, number of panels. Is there a panels? Number of panels in x by y. That's 5%, 7%, 24%. And I guess that's some kind of should amount to 100 somehow. And yeah, So how long does it take? 1.45 seconds. So is this thing telling me that checking all of these things out just takes 1.45 seconds? So I guess my computer is just like way better than that one at the Code Wars server. Like at this point I feel really dumb just paste, test. Yeah, at this point I feel really dumb just like doing this kata, because it's obviously alright, let's say first print n, and I comment out this, comment out this. So we have alright, so first we see that we come to this part and we see to which point of the input do we come to in those 12 seconds. Okay. Yeah, we don't get really far, do we, huh? One, two, three, four. Five zeros. 1, 2, 3, 4, 5 zeros. That's run in 1 second in my computer. So to really test this in my computer and in that computer, it's not comparable, obviously. It wastes a lot of time here. It could be a lot quicker here also. Half of the time wasted just printing. Asynchronous. And what are the tags on this kata, by the way? It's just algorithms. Just algorithms. Are you for real? I just need to like design a fucking algorithm good enough. So say here loops, unrolling, minimizing the work inside loops, sentinel values, putting the busiest loop on the inside. data transformation. Just a sec. Alright. Minimize array references. String length index. Useless, I think. Also, this is useless. Use supplementary indexes. Like, maybe if there is a rule of so it doesn't need to run this loop that many times, so that it says size is like x divided by something, you know. Like if input is 1 2 3 4 5 and we say divide floor by 1 2 3 4 5 by 2, that's 2. Alright, shitty idea, yes, shitty result. Expressions, use Zadring. Okay. Because here it has to do number of panels. Next by Y rectangle, and it has to save those. So I'm doing that. It's like 0.000%. Time in Python is like spend 1% over here, like 2% over here. And this if statement, like most of it is like in this print function. So alright, let's like delete or like comment out this print function so that we can see the other stuff about what's happening, you know. Okay. 33 years, that's 48, 56, 70. Alright, and then it gets, so most of the stuff is spent here, and then some stuff is spent here, and here, size plus 1, size plus 1. So I guess that runs so many times that it wastes so much time. So if we could optimize this, so how can we optimize this? To define size of the biggest cube. Is there a better way to optimize this, you know, because this now runs in our local machine 0.67, 0.64. It's pretty stable, yeah. So it's I know I've looked this up on Stack Overflow. So it's to find an exit while loop in Python. Python loop won't exit the beginner is finding the index of an no, not that. So how to use timeit module. Oh, how to find integer nth roots. I want to find the greatest integer less than or equal to the kth root of n. I tried that. Alright, so I think this is kind of manageable. So we say here, yeah, he tried that. That didn't happen, so this one says solution that's old about, I don't know, 8 years now. It says one solution first brackets, fuck off. One solution first brackets the answer between low and high by repeatedly multiplying high by 2 until n is between low and high. Then uses binary search to compute the exact answer. What? A different solution uses Newton's method, which works perfectly well on integers. So it says I root n and k, so n k to the power of 3. Okay, so it uses that, and it says us, u and s is n and n plus 1. Alright, so that's n and n plus 1, and while u s s u t is k minus 1. STK, what the fuck? Thanks. Test them with Peter's examples, both give correct answers. Yes, both methods do. Nth root to fm. Why not try this or that? Milan, Italia. Math. Yeah, okay, so this is Newton's method. So let's look up this so-called Newton's method. Is a root finding algorithm which produces successfully better approximations to the roots of a real valued function. Okay, well, yeah, I'm not gonna get that, let's be honest. So here we just say define I root. Shit. And we say we take in k and n. You say u and s equals to n and n plus 1, while u is larger than s. So while u is larger than s, what you want to do is to say s equals u, t equals 3 minus 1 is always 2 times s plus n floor divided power as 2, okay, minus 3 minus 1 is 2, and then u equals t slash slash k, and then just return s. Do I delete this? Over here we say the size of the biggest cube. I say print third root equals I root n cube x is cube x. So we see if it misses or if it like breaks, and it broke. Alright, name k is not defined because it ought to be 3, my bad. Okay. Now this thing took most of it. Ah, okay. So this took that and this took that. Sprint thing. Alright, okay, so it returned the same thing. Is it always the same thing? Let's do that again. Yeah, it's the same. Alright, so we say now instead of this one we call that one. So we say here we say cube x equals I root with n. Say is that faster? I root of n, Alright, so that's around 1.05 seconds for all of that. And if we use the function that like the solution that we have already procured before, okay, unindent does not match any other indentation. Okay, 66 seconds, and this is 0. Yeah, alright, so that's a shitty solution. That's I think it's hard we're gonna find anything better than that, to be honest. Yeah, but yeah, that's a solution. I mean, we don't know how we got that, but we got it. Yeah, 6.4. Synchronous I/O, a base class for developing a synchronous socket, cleanup functions, manipulate through audio data, debugger framework, tools for converting between binary and various encoded, bisect, interfaces, calendar, functions for working with calendars, helpers for running Python scripts via the common gateway interface. Now, what is that? So what is common gateway interface? the web server. They execute an external program, typically to process user requests. A scripting language and are commonly referred to as CGI scripts to make compile programs. Some more advanced shit. Configure IFF chunks, mathematical functions for complex numbers. So we check that out. Build line-oriented command interpreters. Facilities to implement read, evaluate, print loops. Encode and decode data and streams. Compile possibly incomplete Python code. Wow. Container data types, conversion functions between RGB and other color systems. Alright. Tools for byte compiling. Call Python source files in a directory tree. Configuration concurrent. Like, what is this? Container data types. Abstract classes for containers. Collections. Container data types. Maybe that would help us. I don't think so. I mean, right now looking at this code, really, man, and we're looking at it for like a couple of hours now. Like, what the fuck? Come on. Come on, look. Where is our percentage? Here's 37 right here. It's most of it. Okay, we can say Python one line if. Can do like this one liner. If else. Is there elif? Expression 1 if condition 1 else, expression 2 if condition 2, and then it's going to be expression n. Else expression 2 if condition that. Okay. So we can use that actually with some research. Let us do so we print size for a number x and use that as a research. So we say, oh, for 7 is used quite a lot. If we say like less, do we get like more of them? 47 is 47 as far as we can see. Okay. Maybe we get more over here. Whoops. Copy that and paste it. so that is an instance where this this code runner is better. Paste. Attempt. My life. So we got quite quickly, we get, oh damn it, there is one necessary print, oh shit, over here. We can attempt 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. That happens pretty quickly. So then we shall say it here in the half, maybe here, like each that one. So we say when does 24 start? Where is the, oh fuck, here. So here we say if x is larger than 0, and then what is the correct syntax if condition 1, else expression 2 if condition 2, else 24 else 24 if condition is that. So we say if x is larger than that, so are we doing this right? Else expression if condition. Alright, and we go somewhere around here. So search for the beginning of 33. It's supposed to be somewhere here. 32, 33. And we do 33 extra if extra else 33 if x is larger than 32769. Else we go again somewhere around here. Else we say 37 if x is larger than 46657. Else go around here, look for the beginning of 42. Okay, let's look for the beginning of 41. Else 41 if that is larger than else 41 if x is larger than 64001. Oh, wrong syntax, of course. Invalid syntax again. So we say expression if condition. start is always expression if condition else, expression if condition. Okay. Expression if condition else, expression if condition else, expression if condition else, expression if condition else, expression if condition. Invalid syntax. I don't know what's invalid about that syntax. Okay. Yeah, it's still invalid syntax. I don't know why. Like here is here the invalid syntax. So invalid syntax is exactly here, while this document is saying there can be multiple of them. Maybe we just need to delete some of them. And so we delete from this if to this if. Test that out. From this if to that if. And delete from. Oh, if this to if this, else check if, so there was no if in between. And now still invalid syntax. Why are you saying invalid? Oh shit, oh my god. Six, 4, 0, 0. Okay. Syntax error. Why? What is going on? What's wrong, man? What the fuck? I don't get it. Let us just research further. Where were we? Configuration file parser. I do not know what edit means. Utilities for with statement context. I don't even know what edit is, and there's a whole library around it. Context variables. I don't know. Maybe. I don't know. I don't even know what edit is. Copy, shallow and deep copy operations. I don't know what edit is. Register pickle support functions. I don't know what that is. C profile, I don't know what that is. Crypt, Unix decrypt function used to check Unix password. I kinda know what that is. CSV, write and read tabular data. Oh, okay, I know what that is. So there's actually, you don't need. Oh, that's collections. It's context, CSV. So you don't need like Python to XML, you just have this CSV. A foreign function library for Python, okay? An interface to the curses library, data classes, date time, database, decimal, differences between objects, helpers for computing differences between objects. Test pieces of code, package supporting the parsing, bootstrapping the pip installer into an existing Python installation or virtual environment. Are you fucking real?